Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Seams by Sober, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have killer cages, where the digits inside each cage sum to the small number in the top left corner. And digits cannot repeat within a cage. So, for example, if this were, say, a 5 here, this would have to be an 8, because these two digits must add up to 13, because they are in a cage with a 13 in the top right corner, top left corner, sorry, and they are the only digits in that cage. So that's an example of how killer cages work. We have Kropke dots, where in cells separated by a black dot, one digit is double the other. So, for example, if this were, say, a 2, this would have to be a 1 or a 4 to maintain the 1 to 2 ratio between them, because there's a black dot between them. And finally, we have digits on an arrow summed to the digit in the attached circle. So, for example, if we had 1, 2, and 4 here, this would have to add up to 7, because the digits along the arrows must add up to the digit that's in the circle. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. There are many things here which are really restrictive. So let's go with all of them. Particularly the most restrictive ones. Here we have 6 unique digits, because again, there are no repeats in a cage, which add up to 21. The only 6 unique digits which can add up to 21 are 1 through 6, right? 1, 2, 3, 4, 5, 6 specifically adds up to 21. And 3 of those digits must add up to the other one. Well, the only combination that works then is 1, 2, and 3 adding up to 6. So this must be 1, 2, 3 here. That forces this to be 6 there. That leaves a 4, 5 pair remaining in the cage. Okay. We also have 5 unique digits adding up to 34. The only 5 unique digits that can add up to 34 are 4 plus 6, 7, 8, 9. Every other combination does not work, because 5 through 9 adds up to 35. If you try to change anything from 4, 6, 7, 8, 9, the problem is you'll get a repeat. So this must be 4, 6, 7, 8, 9. And then the remaining digits of that the remaining digits in that box can only be 1, 2, 3, and 5. Well, we are guaranteed a 5 here, because again, 1, 2, and 3 add up to 6 here. So that means 5 cannot be in the rest of these digits here, and we have 5 unique digits adding up to 15. That's again 1 through 5 there. So we cannot have a 5 here. This must have a 4, which eliminates 4 from the rest of the box. And this has to be 1 through 5 also for this set. 4 can't be here because of the 4 that has to be in this cage having to be in this box here. And we know 5 can't be here because 5 has to be one of these 3 digits here. So this must have a 5 here, which means this can't be 5, and this must have a 4 here. Okay. Remaining digits in this lower right-hand box can only be 6 through 9, because we have a 1 through 5 quintuplet there. We also have 4 digits which add up to 10. That can only be 1 through 4 here. So that's 1 through 4. That eliminates 1 through 4 in the rest of the column, so it's 5 through 9 there. 6 cannot be here, because of the 6 in the box. Also, 6 can't be here because of 6 in the row. So we know this adds up to 25. So the remaining 3 digits in the box have to add up to 45, which is the sum of the digits 1 through 9, minus 25, which is 20. So that must be 20 minus 6 is 14. That leaves this just as 5 and 9. So we have 5 here, and that's 9. That leaves this as 4. That eliminates 9 and 5 in the rest of this box. So this is a 7, 8 pair. That eliminates 7, 8, and 9 in the rest of the column. We have a 6, 7, 8, 9 quadruplet in row 9, which eliminates 6, 7, 8, 9 in the rest of the row. So this can't be 6, 7, 8, or 9. It's 4. That eliminates 4 in the rest of the box. 5 can't be here anymore. Where is the 5 in this lower right-hand box? It can only be here. That eliminates 5 in the rest of the row here. Nine eliminates 9 in the rest of the row here, so that leaves a 7, 8 pair in this lower central box. That eliminates 7, 8 in the rest of that box there. So this is 6, 9 as a pair, which eliminates 6, 9 in the rest of the row. We now have a 7, 8 pair remaining in row 8, which eliminates 7 and 8 in the rest of the row. So this now must be 1 through 4. Where is 4 in this lower left-hand box? Cannot be here because of 4 in the column. Can't be here because of the 1, 2, 3, 4 quadruplet in the column. So it has to be here. And 4 is in a 1-2 ratio only with 2. Because we don't have 7 or 8. We don't have 8 available because of the 7, 8 pair. So this has to be a 2, 4 pair here, which eliminates 2 and 4 in the rest of the box. So this is 1 and 3. 4 eliminates 4 here, so that's 2, which makes this 4. That eliminates 4 here. Where is the 4 in this cage here? Cannot be here because of the 4 in the box, so it can't be here because of 4 in the row. So 4 has to be there. Okay, 4 eliminates also 4 from being here. Where's the 4 in this cage? It has to be here. Okay, what else do we have remaining? So those are the most restrictive parts of these cages. This is 2 digits adding up to 6. It's either 1, 5 or 2, 4, but because of the 5 in the column, this can't be 1, 5, so this becomes 2, 4 as a pair. That eliminates 2 and 4 in the rest of the column, so this can't be 2. It also eliminates... 4 eliminates 4 from being here, so one of these 3 digits has to be a 4 in column 1. We have a 1, 4, 5, 3 quadruplet in column 2. So the remaining digits left have to be 2, 6, 7, 8, 9. 6 again cannot be here because of the 5, 6 pair in the box. These digits have to be next to a black cropy dot. But 7 and 9 can never be next to a black cropy dot, because if you have 7 or 9, you get 3.5 and 4.5. It's the same, actually 5, 7, and 9 can never be next to a black cropy dot. Because if you have them, you get 2.5, 3.5, 4.5. If you double them, you get 10, 14, or 18, none of which are digits. So this cannot be 7 or 9. It's 2, 6, 8 as a triplet, which eliminates 2, 6, 8 in the rest of the column, and 2, 6, 8 in the rest of the box. So this becomes 1, 3, and 4, which eliminates 1 and 3 here. So that's 2. That eliminates 2 in the rest of the box here. We are left with just 1, 3, 8 in this left central box. We are left with 5, 7, 9 in the rest of column 3. 5, 7, 9 adds up to 13 with 4, 6, 8. But this can't be 4 because of 4 in the column. So therefore this can't be 9 to add up to 13. These are 3 unique digits adding up to a single digit. So it's at minimum 6 for this digit that it adds up to. So it's 6, 7, 8, 9. And this can be at best, the highest digit here on the arrow can be at most 1, 2, and 6. So we have 1 through 6 there. Again, 7 and 9 cannot be next to 5, 7, and 9 cannot be next to a black Kropke dot. So none of these could be 5, 7, or 9. We now have a 6, 8 pair in this upper central box, which eliminates 6 in the rest of the box. 6 and 8 in the rest of the box. We cannot have 5, 7, or 9 be here because it's next to the black Kropke dots here. This can't be 5, so where is the 5 in this upper right-hand box? Can't be here, can't be here. It must be in the cage, adding up to 22. Well, 22 minus 5 is 17, and you can only have 8 and 9 adding up to that. So this must be 5, 8, and 9 here, which eliminates 5, 8, and 9 in the rest of the column. This can't be 8, it's 7. That eliminates 7 there, so that's 8 and 7. Also, 5, 8, 9 eliminate 5, 8, 9 in the rest of the box here. So where is 7? 7 can't be next to a black Kropke dot, so 7 has to be there. That just leaves 1, 3, and 6 remaining in this upper right-hand box. 3 can only be in a 1 to 2 ratio with 6. Therefore, where is the 6 here? It has to be here. So this is 6, that's 3. That means this adds up to 6. This is not 6, it's 8, which makes that 5 and 8 there. This can't be 5 because of 5 in the column and 7 in the row, so that's 9, which makes that 7. 5 and 8 eliminate 5 and 8 here, so that's 9. So this cannot be 8 here. This is no longer 3. 6 is only in a 1 to 2 ratio with 3, and 1 is only in a 1 to 2 ratio with 2, so this must be 2, 3 as a pair, which to add up to 6 must add up with 1 to add up to 6. This 2, 3 pair eliminates 2, 3 in the rest of the column, so this can't be 2 or 3, it's 1. This can't be 1, 2, or 3, it's 5, which means this can't be 1 or 5, and this can't be 1. 1 and 6 eliminates, this 1 eliminates 1 here. And therefore, in this cage here, or it's specifically this box, the 1 has to be one of these two digits. 7 eliminates 7 here. This can't be 8 or 9 because of the 5, 8, 9 triplet in the column, so this can't be 8 or 9, it's 6. That eliminates 6 in the rest of the box. We are left with 1, 2, or 3 here. This cell cannot be in these two cells in this lower right-hand box. It must be the same as that. So this cannot be 1. So this digit must be the same as this, which must be the same as this, because each of these is 1, 2, 3 as a triplet, right? So this digit cannot be these digits here. It has to be in it, but it has to be in this cage here, so it must be here. Cannot be these digits, but again, it has to be in this cage here, so it's there. This matches this one, so this is the same as that. So this is not 2, it's 1 or 3. Okay. 2 can... Okay, so this adds up to 18. It's 1, 3, 6, which adds up to 10 plus 8. That eliminates 8 in the rest of the column, so that's 9 and 8 there. 3 eliminates 3 here. So the blue 2, 3 is a 2. That means this can't be 2 here. This can't be 2 here. This is not 3 and 6, so this can't be 3 or 6. 8 eliminates 8 here, so this can't be 4. The reason why is this can't be 2 and 4 is we have to have the 8 be in a 1 to 2 ratio with a digit, which can only be with 4. So 8 has to be one of these next to a 4 here. We have, this is either 1, 2, or 3, 6. So we have a guaranteed 2 or 3 here. This is guaranteed 2 or 3, which eliminates 2 or 3 in the rest of the row, so this can't be 2. That's 4, which makes this not 4. That's 2. 2 eliminates 2 here, so that's 3, which makes that 2. So neither of these can be 2, which makes that 6 and 3. 2 is in a 1 to 2 ratio with 1. 1 means this can't be 1, it's 6. This can't be 2, 6, so this must be 8 and 4. That eliminates 4 and 8 here, so that's 2 and 1. 8 eliminates 8 here, so that's 5 and 8. Okay, so we have... 1 eliminates 1 here, so that's 3 and 1. 2 eliminates 2 here, so that's 3. Okay, so these two are the same. We don't need the blues. We do have 8 2s, though, so we know where the last 2 has to be. It has to be there. 1, we don't have enough information. 8 eliminates 8 from being here, so we have a 1 3 pair here. That is helpful. That means where's 8 in column 3? It has to be here. So this can't be orange. We'll make this then dark. That makes this orange here. Actually, let's make it green. That's green. This is orange. That makes this not orange, so that's green. So we have orange here, orange here, orange here. Where are 1 and 3 in the central box? Can't be here because of the 1, 3 in the columns. Can't be here because of the 1, 3 pair in the row. So one of them's here. That means the other one is here, which means that's the orange 1, 3. This adds up to 12 without 2 and 4 and 8. So the possibilities, you cannot have both 1 and 3 there. Well, you couldn't have that because of 1, 3, 8. Let's just go actually look at remaining digits of column 7. We have 5 and 7. Remaining digits of column 8. We have 1, 3, 6, and 9. 9 cannot be here. This can't be 1, 3 anyways because of the 1, 3 pair in the row. But 9 can't be here because 9 would have to be with 1 and 2 to add up to 12. So whereas 9, 9 has to be here. Therefore, we have a guaranteed 6 here. And we can only add up to 12 with 1 and 5. So then this must be 1, 6, and 5. That eliminates 5 here, so it's 7. That leaves orange as 3. And green as 1. 1 eliminates 1 here, so that's 6 and 1. 3 eliminates 3 there, so that's 1. 5 eliminates 5 here, so it's 6 and 5. And the rest is just normal Sudoku. We have all the 1s, I believe. We do. We have all the 2s now. We have all the 3s. 4. Where is 4 in this upper central box? Can't be here because of 4 in the column. Can't be here because of 4 in the row, so that leaves this as a 4. That gives us 8 4s. We know where the last 4 has to be. It has to be there. 5. 5 in row 1 can only be there. We have 8 5s left, which leaves us the last 5 having to be there. 6. Where is 6 in the central box? Cannot be here or here because of 6 in the rows. Can't be here because of 6 in the columns. So that leaves 6 there. So this makes that 9, which makes that 6. And that gives us all the 6s left. 7s. In row 2, 7 has to be there. That eliminates 7 here, so that's 8 and 7. That means in this central box, where is the 7? Cannot be here because of 7 in the column, so 7 has to be there, which makes this 9 and 7. And that gives us all the 7s. 8s. We have 8 8s. The last 8 is there. 9s is only in the remaining spots. So that's 9 and 9. And that's a solution. Yeah, pretty straightforward. It's basically a lot of restriction by the killer cages. We didn't even, well, I guess we didn't have to, because 1, 2, 3, 4 is 10, plus 7 and 8 is 25. But, yeah, these were really restrictive, so it was very clear about how to go about solving this, because of the restrictions. So, yeah, pretty straightforward. But nice flow throughout the puzzle. It flowed very well throughout the puzzle. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.